new document, go on, press 1, and no, I don't want to save this. And I'm going to add a calculator, and I want to look at this data over here and enter it to matrix. So I'm going to do menu 1 1, and I'm going to say call this G for grades, say equals. Then between the 9 and the book is a matrix key or toolbox key, and if you look on the second row in the 1 2 3 4 5 6 place, this has 3 students with 3 grades, and the grades are starting with 100. You type in the number and then you press the tab key. 100. I would recommend you use your left hand for the tab key and the right hand for the numbers. 50, tab, 0, tab, and you see it automatically. I don't even have to look. It'll automatically go to the next row. So just keep reading the numbers. 0, 50, 100, 0, 100, 100. So that's 0, tab, 50, tab, 0, tab, 0, tab, 100, tab, 100.
You don't have to use a mouse. You can just press tab on the computer, on the keyboard.
So I am modeling what a student would be doing on their with a calculator. Yeah.
Sorry.
Now I had to go up and correct an error. Usually I don't have to do that. So tab, 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 tab. Then I press enter, and there it is. Now. That's how I enter data. If I wanted to do something to the data, like double it, I could just type 2 times G, and it would. What do you think it's going to do? Double each number inside the matrix, right? So that's 2G, enter, and you see that it does double all the entries. Okay, let's add a page, a calculator page. A calculator page. Let's try that again. I meant a calculator page. And what I want to do now is I want to be able to do the assignment, solving a matrix equation in a linear system. So let's look at the first example here. Here, our objective is to use matrices to write a matrix equation and solve it. The way we're going to do it is like this. Here's our first problem we could use. It's about ice cream, the 2 ice cream things. They're selling these kind of ice creams and those sundaes. And apparently it says here that the extra large, the ice cream shop sold 15 small chocolate. And 25 chocolate cones. And that cost that much money. Then they had small what color is that? Let's see. That's 15 and 25 is 220. Look at the first equation. Oh, I guess we're going to do that later. So, my bad. Let's do this system right here. So, menu 1, 6. Then I can do the toolbar here. And I can write this.
Good luck, my slime.
And this would be 3x minus 5y equals 11. And I don't know that I need this. And this is 7x minus y equals 15. Okay, okay, interesting. Trying something new. So how do I write this as a matrix? I do not menu. Recording. So writing and solving a matrix equation into a linear system. How do I do that? Here's our 2 different types of shakes or ice creams, small and big. We're going to talk about how to solve that in a moment. But first, let's just talk about a system of equations. Now this, traditionally, there's a way to solve this using menu, algebra 1, like this, solve a system. Here's one way to do it. and I would just linear solve, and then I would write 3x minus 5y equals 11, tab 7x minus y equals 15. And there it is. That's what they showed you. So this is a way you can, there's a built-in computer program to do this. Let's open up another screen, another calculator screen right there, and let's do it with matrices. How do I do this in matrices? Well, I can get my system, and I could do it like this. What was my system? It was 3, 5, 11, 7, negative 1, 15. Find the matrix tool right here. It's 2 variables and 2 unknowns. Click on this matrix, press enter, and now we're going to type in the numbers. 3, tab, negative 5, tab, 7, tab, negative 1, tab. I have to find the inverse of the matrix. Find the shift key, the power key, power to negative 1, tab. Okay, you can press times or not. It'll do it by itself. And click on the matrix thing. And I need 2 by 1, which is this one right here. Click it, press enter. The two numbers are 11 and 15. 11, tab, 15, tab, enter. The answer is 2, negative 1. Does that agree with this? Let's look. Here is how you do it by hand. I will show you how to do that later. This week we're just learning how to ask the computer to do it. And here is in general what we're doing. You see see A, B, C, D? That's the first matrix. We call it the coefficient matrix. You see the E and the F? You see the E and the F? That's the constants. So this is the constants matrix. This first thing is called A. This variable matrix is called X, XY, and EF is called B. We set up an equation AX equals B. We multiply both sides by the inverse matrix. A inverse times A is I times X is X. So the answer is always going to be A inverse B. That's what I did here. So here's another way to do the same thing using letters like that. Okay, let's do the next one using letters. So, okay, let's do the second one, again the same way. It's 3, 4, negative 14, negative 2, 1, 9. So, let's try this again. It's an X and a Y twice. So, if you think of it like a square, here's the square. So let's get the matrix square. Get the matrix, find the 2 by 2, press enter. Let's type the numbers in. 3, tab, 4, tab, negative 2, tab, 1. Out, then press tab. Press tab and then 1, tab. Then I need the inverse of this matrix. So it's to the power of negative 1. I could press enter if I wanted to, but I'm not going to. Tab, and then I need the other matrix. So click on the tool again, but this is 2 by 2. I need 2 by 1. That one. Okay? And then press enter. Then we put in the numbers. What is it? Negative 14. And then press tab, then negative 9. And then press tab. Then press enter. What does this mean? This means that when I multiply 3, 4, negative 2, 1 by that, 2, negative 5, I get negative 14, 9. This is what this means. We're solving the matrix equation. I didn't know what this was till I found the inverse matrix. Yeah? So that's the essential question. Can I invert the coefficient matrix? Okay, that's example 2. Let's pause a moment. If we continue this, there's another way to do this. We could, here's the one with words. Tommy and Max have a lawn care business. They both charge an hour for mowing and raking leaves. Okay, 10 hours and 6 hours is 114. So I can tell that I can highlight this. It's 10. That's the first equation. And That's the second equation, yeah? So what does that mean? Let's see. Let's put the matrix. 2 by 2. And what do we know? We know that it was 10 and 6. It's 10 for mowing lawns, 6 for the raking, and then 8, and I can't see the other one, 9. So that's 9. Then shift it. Where's the shift? Raise it to the power of the -1. Then tab. And then I need the other matrix. How much do they charge? They charged, the charging was 114, and the other one was 118. Oops. Okay. 114 and 118.50. So apparently this is the result. 7.5, 6.5. What is that? That's how many things they did. Assuming both charge the same rate for each service, how much do they charge per hour for mowing? For mowing, 7.5. For raking leaves, 6.50. And that's that. Moving on to the next lesson. Let's move on to the next section. How do we do this? You can look at those problems. Here's 7.3. So let's take a look at that. When you get the message singular matrix, that means there's no unique solution. That means it's not the kind where that means that a unique solution means you get an answer, okay? But if you get this message right here, and I'll show you in a moment that you can get that message. You can get that message when you can't find the inverse matrix. So it's either infinite or no solution. Here again is the algebra. And here again is an example. So let's do this. Let's find one that's bigger. Let's find a 3 by 3. Here's one. Well, here's how to get the inverse, yeah? That's a 2 by 2. Here's a 3 by 3. Okay, so in honor of that, let's go to this and calculator and do a new page. Okay, do matrix, go to 3 by 3. Press enter. Okay, so you press enter and we're going to enter the data. How many X's do I have on the first row? 3. Press tab. How many Y's do I have? -5. Press tab. How many Z's? I have 1 Z. Press tab. How many X's in the second row? -4. Press tab. How many Y's? 3. Press tab. How many Z's? -2. Press tab. How many on the third row of X's? 7. Press tab. How many Y's? 1. How nice that they put them in order. You know they don't have to. -3. Press tab. But they did put them in order. If they're out of order, put them in order. Okay. Raise it to the power of -1 because I want the inverse. If I just want the inverse, I would press enter and get the answer. If I want to solve it, press tab. Then this is a tricky part. Press the matrix tool. Press the same 3 by 3. But I don't want 3 by 3. Press tab and delete. I want 3 by 1. I want 3 rows and 1 column. Press enter. What's the first number? Class? -24. What's the next number? 9. What's the next number? Let's write that down. -24. Then after there's the number, press tab. After the number, press tab. After the number, press tab. And then tab. And then enter. And there's the answer, -2, 5, and 7. Does that agree? Yes. Now look at the fancy way they did it. Like this. Can I do that here? Yes. Watch. I'm going to say define A equals this. Then define B equals, of course, I'm cutting and pasting. I would normally just type it, but I have a keyboard, so yeah. So that's A and B. Now I want to do something with A and B. I want to write A to the power of -1 times B. Press enter. Oh, wait a minute. Look at that. I forgot to press tab. What did I tell you? A to the power of -1. Press tab. Then press B. It'll do it by itself. Some computers won't. This one does. And so that matches what they did in the lesson over here. Thank you. There's another way I can do this. I can do menu, matrix, and I can do row reduced echelon form, REF. So I could have just spelled REF. All right, and then I can put in the matrix. What was the matrix? What was the matrix? It was a 3x3 matrix. Well, I can do a 4x4. Okay, let me delete this then. Let's do a particular one. I'm just going to make up. This is a 1, 2, 3, 4. Recording. So we did a 3x4, and someone showed me a problem. It's a system. I guess maybe I should write it up there, but I'm just going to give you the numbers. It's 2, 1, and then a 3, then a -1. But there's a problem here. This one has 1, 2, 3, 4 equations and 4 unknowns. I am missing the. It's supposed to be a 4 by 1, 2, 3, 4 by 4. That I was going to take one more minute. You might have noticed I just deleted the last thing I did because I want to take one more minute to do this again. So what I'm going to do is I'm going to copy this. In fact, I'm going to copy this whole thing like this, and I'm going to reinterpret it. Instead of, I'm going to do REF, and I can do that, or I can do menu, then matrices, matrix and vector, and reduce row echelon form is right here. It just types that. Then I'm going to go up here, and I do toolbar matrix. This is going to be 3 rows by 4 columns. Why? Because it's 3, tab, -5, tab, 1, tab, -24. I'm going to add the column of constants. Notice that I'm putting in the matrix. I'm putting the 2 matrices together. This is called augmenting the matrix. And reducing it like this gives me reduced echelon form. Now, if I want to solve it, I can do RREF. I could go like this and then reduce row echelon form. I could just type it as well. See, I could just type RREF, parentheses, or I could do this. Duh, I should have thought of that. Do that. And that gives me the same answers. How do I read the matrix backwards? This first row tells me that X, with no Y's, no Z's, is -2. And Y, without an X, without a Z, is 5. And this is an equation that has no X's and no Y's, but a Z is 7. So apparently the answer is -2, 5, and 7. Okay, one last problem for 7.3 is after you do this, let us do a word problem where we solve it. And here's one, number 14. Maria, Rebecca, and Sally are selling baked goods for their math club. Maria sold 15 cookies, 20 brownies, 12 cupcakes, raised $23.50. Rebecca sold 22 cookies, 10 brownies, 11 cupcakes, raised $19.85. And Sally, she sold 16 cookies, 5 brownies, and 8 cupcakes for a total of $13.30. How much did they charge for each baked good? Easily, I can do this. I can either do the augmented matrix or the other kind of matrix. So RREF, parentheses, if I do it this way, that would be 3 types of cookies, but with including the how much I made, that's 4 columns. So let's go over it again. How what was it again? Of each kind? Let's see. Try here. So let us write 15 tab, 20 tab, 12 tab for 23.50. Then the next person, they did 22, 11, 22, not 11. I lied to you. It was 10. And 11 cupcakes for 1985. And finally, see you later. Finally, this other person, they did, what did they do? Let's put this in. They did 16, 5, and 8. 16, 5, and 8 for 13.30. So those are the facts. And so I open up the calculator and I say, press enter, and there's my answer, 30 cents, 50 cents, and 75 cents. I could have also done the matrix equation by 3 by 3. Let me show you that real quick. Where you go 15, 20, 12, 12, and 22, 10, 11, 16, 5, and 8 to the power of the negative 1. And I press tab. Then I press this matrix thingy. I delete a tab and I delete this 3, make a 1. Press enter. Type in the money. 23.50. 1985 and 13.30. And you see, there it is. And if you round this thing, to the nearest cent, you get the same answer. Anyway, those are the two ways to do it.